Okay, it's 7 after, so maybe Rekal, you can get going. Usually Sunday mornings will
Yeah.
kind of roll in more like 10 after rather than 5 after. So we should probably
Okay.
get
Sure.
started and then people will join in, I hope.
That sounds good. Cool. So today, just kind of going to go through GetAtra and this ad delegates that has been introduced with FastAI, and that is really nice in giving the ability to still continue using star quarks, but at the same time, you have the ability to kind of see your whole parameter list instead of ending up seeing star quarks, like for example, like in Matplotlib. Um, yeah, just going through the simple example that's there in the link on the FastAI web. This one. Yeah, this guy making delegation work in Python. So look at two cases. One was inherit when you inherit, and the other one was for composition. Um, so in this case, you're basically creating this class web pages, which has these attributes that you have, or the parameter list that is there of title, category, date, and author. You use to build that inherit from web page to build product page. And you basically just want to kind of tweak a few things around concept of inheritance. You just want to go ahead and add for this years, you basically say price and cost, and you want to ship the rest off to web page. So if we run that, and if we do this, yeah, this is the simplest way. So you still end up with these star quarks, and this kind of inconvenient, painful, simple solution is just basically adding this decorator, add delegates, and then when we do that, that kind of ships it off, and then now you can see the whole parameter list. In essence, yeah, that's pretty much the story. Um, Collab has a few issues. Um, doesn't really work well with the parameter list in general, so nothing really to do with the delegates or the problem with that as such, but just a heads up on that. The other scenario was delegated composition. This was when you were composing. So you basically have, again, this product page, and kind of using, you build this web page, same instance where you're using this web page that we have built, and kind of build the product page with that. Here the problem is when you're trying to access something from this one which you've composed with, you have to use those attributes. So P page is your product page. And if you want to access the author, a problem is you have to go down to the web page. So that's why it goes p page dot web page dot author. So now the whole idea is to kind of get rid of using this, make it convenient for the user, just do page dot author, and we should be able to get so this the easiest solution is using getAtra. We know getAtra basically, if you ask for an attribute and if the attribute doesn't exist, you can kind of handle that case. So getAtra is the one which kind of helps you get around that. So if you just have getAtra is going to get called when you do p underscore page dot author doesn't find author. So now you know you can catch it with this. And how you deal with that is you basically ship it off to self.w.page. So you're saying if you can't find it in p page, you basically go to self.w page and use that K to find it. So that K is the author. So now if we do that, that should run. Oops, page is not defined. So then that solves that problem. But yeah, like the two things that we've lost is this tab completion stuff, and sorry, we lost our tab completion. So Python calls underscore dir to figure out what attributes are provided by an object, so we can override it and list the attributes of the self.w pages, self.w underscore pages as well. So that's just what is called and what you need to update. Um, control which attributes are forwarded to the composed object. We should consider providing a list of forwarded attributes to use that in both getAttra and dir. Now, to kind of combine these two and put them up together, he creates getAttra, this capital G, capital A1, and default is the one which kind of will relate to this like self.w page, which basically says, if you don't find it in me, where to go find it. That's the default. And then you can use these other attributes like underscore at extra attribute, which basically limits what you're forwarding to this compose function. So let's look at a quick example to see if that makes sense. So this is the case where we said, okay, we can handle with getAttra. And the main thing was you passed the self.w page as the new guy to look in if you don't find it in product page. So something very similar happens here because we are inheriting from getAttra. We have to set this self.default, and that becomes basically W page. So that just says that don't find it in me, go look in here, and everything else just works. That's pretty much it with the getAttra stuff. Now to look at what is happening with FastAI, run a few examples here. Let's see. So let's look at the easy one first. Okay, so this is the CNN learner. And if you remember the FastAI stuff, so CNN learner basically is setting up the learner for convolutional neural networks. And it's a learner. So basically it has to kind of ship things off to the learner at the end of the day, and that's what happens. Just to remind everyone, learners are basically just a combination of your data, your model. Those are the main things. You can set in your loss function. This just says where you want to kind of freeze and unfreeze stuff. Of other quarks that you can pass in, which basically are connected with the learner, like for example, your optimizer and the other kind of things. So it's kind of just a wrapper which holds all these things together, or a container. Um, so actually in code, Jeremy seems to be using learner dot underscore underscore init. And by default, the way getAttra, I'm sorry, by default, the way this is set, if I'm not wrong, is it uh, it basically accesses this. So you don't need to really pass in that function, that method. So let's look at that, and actually first let's look at if we just do this, you can clearly see you end up with these quarks here again. And if you use the delegates and say from where you want your stuff, and then see the whole parameter list is kind of seen. Um, yeah, this I was just doing a test that even if you don't use the init, everything should work fine. And yep, it shows the whole list. So I don't think that is required there. So that is that example. Um, Otherwise, basically, the problem which we were seeing over here, you have to type this extra thing of product page dot web page dot author. That you can kind of see is in the case of these data loaders, right? So if we look at data loaders, this is data loaders. Uh, this is data loaders. And what is happening is you're inheriting from getAtra, you've set this default to be trained, which basically means whenever you're accessing your data loaders, in this case, if you don't find something in data loaders, you're going to kind of specifically look uh, with this extra attribute in between. So uh, let's see the example makes more sense. Okay, so this is what we are used to doing, right? DLS dot show batch. Uh, where is this looking at is at the training. And if you remember, this is kind of the stuff we do right at the initial stage. After you create your data loaders, you see a few of the images in your batch. This is where you would have performed your augmentation and all that. So you're looking at your input image, which basically is your training set. So you're looking if your training set is looking right before it goes in for training. And this is what you're kind of saving instead of typing this dls.train.showbatch, which basically would give you the same thing. So yeah, that's pretty much all I have. Yep. Yeah, I think that's all I have, Srinivas.
Okay, sounds good. And so we'll jump and look at a couple of, let me start sharing my notebook. Let's see which one is the one that I think that's the one. Let me know if you see my notebook.
Yep.
Okay, so editorial comment, it kind of, Jeremy has actually introduced, I think, or shifted around stuff even from when a few weeks back I copied the foundation notebook. So he has moved getAtra and stuff from foundations to a different notebook called basics within fastcore itself. um, and but we'll get to the basics notebook right after we look at um, the foundation notebooks that we are currently going through. We are looking at the L helpers, that is for the L class. And actually, that's the next one, Rachel, if you can um, look at various usages of L in FastAI. Maybe next time you can just kind of
Yep.
highlight the different aspects once we go through the various aspects and where he maybe uses different um, features of L from
Right.
FastAI. That'd be
Yep.
great.
Mm-hmm.
So the L helpers actually are classes that he creates um, in order to uh, build the L class. So hopefully it doesn't log me out. For that would be not a good thing, but let's see. Let me continue the, so as we saw, and we kind of rushed through this, so I just wanted to spend a minute. L is a collection. So what we do before we create, or what he does before he creates the L class, is use the collection base. That's a base class which composes a list of items. And so it's delegating to the list, and it builds or composes around a list. So essentially self.items, and then is passed in as the value to the collection base. And then, you know, all the various dunder methods for it are utilized, except he modifies some of them so that he can create a better or more suitable L class, which provides some features that the basic list doesn't from Python, and that's kind of the reason he's doing this get items and set items. If you see, it would traditionally for a list, it would have just returned self dot items, but here he does self dot items and off, and then if k is already of type collection base, then he builds a list of k, and that we'll see is very useful to support certain features in the collections or in L that a list doesn't support. So that's the reason he kind of does that uh, piece of it, if you will. Especially, we'll come back to it. It'll make more sense when we actually look at what how we use it. So here it's just a collection base, and we pass in items, which is a list. So the length is 5, the last item is 5. You can kind of set 2 to be 100 and then check it. You can delete the stuff, then obviously length reduces, and then you can convert it to a string and check what the values are. So this test is fairly self-explanatory. Now, one other thing, I touched on it last time. We'll get into the details of the meta class again later. But bottom line, what he is doing here is replacing the dunder call of the meta class that he uses to build the L class. So you can see the meta class he passes in is this L meta or underscore or underscore L underscore meta, and replaces what he does there is he replaces the call. And what he does in the call is, if x is not none, that means you pass and this class and is and x is a class, then he returns x itself, which means basically it does what I noted in the comments, that is L of L will give you back the exact object that you started with rather than creating a new one, which is what a list of list will do. So a list of list and the original list will not be the same object. Here, an L of something will be exactly the same object that you started with, or exactly the same object that the original L is. So if you test with an is, as we'll see later, it will give you true. Then he uses those three things to inherit from. So he has get itra, which Rekil just went through. So that means it'll, you can see right away that the underscore default is to items. That means anything you pass, it delegates to items as the class that it wraps L around, right? So you don't have to do this, what Rekil just went through. You don't have to do the train, so you don't have to do the items dot. You can just do L dot, and it'll actually return you from that attribute. And then it's a collection, so it's the collection base that it inherits from. So that works as well. And then the meta class is this. So we'll just run the two if my connection is not lost. It's kind of misbehaving a little bit today. Don't know why. Do not want to exit. Okay, thank you. Ah, my connection or the allocation is kind of intermittent, so it's going to complain. should work. Let's disconnect. Okay, good. Okay, so we'll look at the L code. Quite a bit of problems with notebooks today. Okay, and then this is all the docs that we add. Again, recall that this itself is also a decorator. Okay, and so this is a detail that he uses to reload the appropriate signature. I don't know why he does it this way, but he's actually dumping lots of save field. He's dumping the inspected signature of the call method, blah, 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 and then reloading it. I don't know why he does it this way, because there is, when I looked into it, simpler message, maybe he was just not aware of it and he may update it. But what he's doing here is that when he uses the meta class, apparently the signature gets hidden or shadowed, and so he kind of dumps it and then loads the signature back again. That's all he's doing in these two cells. I wonder whether it was something that I was trying to run the notebook for a while to get to the L. I don't know whether that's causing these problems. I don't know why it's not responding so often. That's the reason I can't run the cells. Sorry about that. Okay, here we go. My connection is fairly good, but it seems to be dropping the connection quite often. I don't know why. Okay, and then basically register L as a sequence. So L is a drop-in replacement. We already looked at some of the basic explanations. You can see that, the utilities, from the utilities, you can spend some time looking at fastcore.utils, imports things like GT, which basically helps you do things like this. And we'll get into item got what that is, but basically it says, let's make from the dictionary, let's build an L class. Item got one basically is get the attribute 1, then map the abs function onto it, filter the result such that you apply greater than 4 to the result of the abs onto the first attribute. And since there's only single, so it'll apply it to all these attributes and then sum it. And if you see, because it is doing an abs and it's saying greater than 4, so it just adds these 3 elements and gets 20. So we had kind of looked at the quick tutorial of L, but let's now look at the code of L. Okay, so if we look at it, any iterable can be passed into L. So you can see that range of 12. So you just check that T, which is an L class, is 12 values. It's not equal to range of 11, obviously, because it has 12 values, not 11. Now, the interesting thing is he also does or asks this question, and I thought that was worth spending a little bit of time on. See, here he uses from the L class T dot reverse. So what it does is obviously reverses the L, which is 0 to 11, and flips it around to be 11 to 0. So that's where T0 after the reverse, if you check, becomes 11. But the interesting question he has in the lecture is, if you look above at the code of the L class, if I can get to my, I hope it doesn't again say it's stuck, but it's really been a pain today. I don't know whether it's the multiple savings of the notebook that's causing the problems or what, but it's this unresponsiveness is pretty bad today. Okay, hopefully we're past that. Okay, now if we look at the L code here, what you will find, and if you pay attention to all these methods, there's no reverse method at all, right? There's literally no reverse method in the L code. So how does T dot reverse work?
Is
When
it
you call
shipping
T
it off to
dot
list?
reverse? Sorry?
Is it shipping it off to list?
Yep. That's exactly what's happening, because you're composing it and then passing it on down to the list. So list as a reverse. So that's how T dot reverse works actually. I thought that was interesting because basically it's, you get that through the collection base and through the items thing, you're composing it. And so you just ship off the reverse to the list. And that's how you get T dot reverse to work. Now, these are the interesting ones. So you can set a single item, T3 is H, then you check that T3 is equal to H. So that is not a big deal because that will work in L also. But the next one is a big deal. And see, T3 5, you can set multiple values and you can see here that they are not contiguous. So it's not a slice. It's actually individual values that are being set. And that's where if you look in the collection base code where it does the set item, get item, and also in the L code of how individual items are set, then you see what happens, which helps support the 3 and the 5 to be set as different values. So for get as well as for set, that's where let's look at the get item, because the get item also for 3 5 it will get you both the 3 and the 5 or two values. And here's how all that works, or the code in L that supports it. So first it checks um, or when you go to get item, which is what is used to get the items, and you pass in idx, so in this case it would be 3 and 5, then you return self dot underscore get idx if idx is an indexer. And an indexer is something which is a single element that is used to index into it. Otherwise, you do L of self dot get idx, and use list is none. Use list is none. Just think of, ignore this for a minute because use list is still passed in as none. We'll kind of look at the special case of when use list is true and therefore it uses it as a list. But let's stick with the case where this is none. Then it goes to self dot underscore get of idx. So now here's where we are, because it's not an indexer, because an indexer would mean a single value. And it's not a single value, we're passing in a 3 comma 5. So then it goes to this part of the code, which goes here, and here's what it does. If indexer self whether self dot items has the attribute ilock, and if not, return self dot items I. So and so that's what this does. If it's indexer I or is instance I slice, then obviously you get the attribute ilock and self, the default value is self dot items of I. So in this case handles the data frame situation, or just passing in to the I value. Then if not, then convert the mass to IDs, which we saw earlier in this notebook itself, so that if mass to IDs, remember, if they are Boolean, then they get converted to indexes. So that's what happens to mass to IDXI becomes I. And then you return, and if none of, and then if ilock, then return appropriate value. Also check for array, which is what this does, dunder array. And now if L doesn't have those, it then returns a comprehension of values. This comprehension of values that it returns is what enables it to return 3 and 5 instead of a list, which will not work when you supply the tuple 3 comma 5. Because here through this list comprehension, it's passing it to the list, and it's actually the list is then doing self dot items I underscore for I underscore in I. So that means here I is 3 5, and for I underscore in 3 5, that means for 3 and for 5, it'll return self dot items 3 and self dot items 5. So this code of how it handles how L class handles the get item and the set item using the indexer and special casing the ilock, the arrays, and the mass is what enables the L class's ability to index into data frames or mass indices or into a list, but also support multiple individual non-contiguous items returnable from L. So that's what enables you to do this. In this case, we are looking at it for set, but it's the same kind of code that works for a get, right? So this will not work for a list, but here it does. T35 is JK, and then you can check that it's set to J and K. And then you're also checking that T, and if you now remember, T is already L of range of whatever with these changes. Check that T, and you make an L of T. Now T is already an L. So L of that range is the same. It's equal. And in fact, we'll later see that it's the same object. So it's not even just equal, it's test is will return true. And you can see that even here is doing the same thing. L of 1, 2, 3, 4 is, and the L of that is the same as the original elements that you pass into it. Any questions on any of this? Okay, and then moving on. So L is also a sequence. And the reason that is helpful is because then you can, if it is a sequence, then you can do random samples and stuff like that. It's much like L in that regard. So is it a sequence? And obviously it'll say yes or true. You can import random, and you can sample from T, 3 values from tree. And then you can check that you can build a list of lists, and then x0 obviously will be the 0th element, and you're setting that to 1, 2, and then you're checking test equals blah blah blah, and L1, 2, this 1, 2, 3 has been replaced by 1, 2, as you can see here. Oh boy, I'm really having trouble with notebooks today for some reason. And it's gone into the not responsive mode again. Yeah. Don't know what is the problem.
Do you want to share your notebook with me and I can run? It'll be slightly harder, but
yeah, but you'd have to get back to the same point, right? That's what I was trying to avoid. But I mean, it may take a few minutes, but it may be worth it. Do you want to? I'll need to ship the notebook to you, correct?
yeah, I have to download it and send it across.
Yeah. The other thing I might try is just, if people are okay with it, is just get out and reopen it. It'll just take a while to get back to the spot.
You can
Is
try
that
that too.
okay with people? Then I'll just go do that. Just doesn't even matter that I've saved it or not, because I think, yeah. I was also trying to do the basics notebook. Maybe that was too ambitious. I was trying to keep the notebooks alive. Maybe that was too aggressive on my part. Sorry about that. I hate to waste people's time. It looks like I have no alternative.
Hello, Srinivas. I want
Yes.
to ask, do you use Collab Pro?
Yes.
And are you based in US?
No, I'm actually in India right now, but it's not been a problem because I'm based in the US, so I paid and used Colab from there. So I've never had a problem after I moved or temporarily came to India for a month or two, and it's been working the last several weeks. Also, I've been using it from India. So, last week or 2 weeks back, no problems of this kind. So I was wondering whether it's the network, but my network indications are fairly strong. So I don't know what's the problem today.
Yes.
Kind of really, and in fact, funnily enough, I went through this notebook and the other notebook this morning just to make sure things were all set up right and everything ran perfectly. So I am very puzzled by what's going on. Sorry about that.
And about those saving issues, I think that started after they changed the Google Drive policy somehow, right?
Oh yeah, they changed, but that was only, I thought, for what is that called, like the trash. They said after a month we'll get rid of what is in your trash. I was like, thank you. Anyways, it was a problem that you weren't getting rid of it. So
Yeah, I just saw it mentioned somewhere,
oh really?
probably in FastAI Discord or something, and someone, I guess it was Zach, who said that after some changes, like working from Google Drive became much slower. So, for example, you need to load all your data into your environment and work from there. You can't interactively load from a drive because it's much slower. And I guess that those saving issues might also be like related with some timing.
Yeah, of
Weird
save,
timings.
and they said the backend seems to be definitely experiencing some sync issues because it never gave me as many problems as it has recently.
Yeah.
And of course, I'm on a not very powerful laptop that I took with me while I was traveling. So hopefully this thing will. Yes, even last week. I mean, so far the last 2 months I've been, since November and most of this month I've been in India doing. In fact, even running the Kaggle stuff from here, and even last night I was working on the Kaggle notebook and doing a bunch of stuff. It didn't do this. It's kind of really weird. What's happening? Yeah, the other thing I saw, as I was mentioning, was Jemmy meanwhile had moved stuff around. So he moved Getatra from this notebook, which is, I think, the foundations, to something called basics. And even in basics, the funny thing I saw, and I haven't yet gone and commented on it in the Discord channels or whatever, but uh, he uses, or he, okay, let me see whether I can get this running. And at least when we get to that notebook, you'll see that he defines getatra way down in the notebook, but he uses this in a cell far above. So I was like, it's very slow too, because usually this mounting happens very quickly. Oh, see, it's again connecting, reconnecting. So maybe it is my connections. That's the case. Maybe I should do what Raquel suggested, even though my network is okay. Let me try and ship the notebook to Raquel because I see the connection disconnection happening too frequently. So I don't know whether that's the cause of the problem and something with the network thing, because it lost it and then it's again connecting to the back end. So let me download and ship this notebook.
Can you just share access without downloading? I think you should be able to, right?
Yeah, I believe that should be doable. Let's see. I would have to open the notebook and then share, right?
If I'm not wrong, yeah, that's correct.
Oh, I can just do this.
Ah, yeah, there also that works too, I think.
No,
You can just do that copy link.
no,
Or that.
that's not the one. That is not you. The
REKIL.
no, Planet should work. No.
No, REKIL.
Ah, there.
Yeah, that one.
That's the one.
Yep.
Okay.
I don't think it grabbed the word.
Yeah, let me see whether also I can send you a link. So in case. Okay, now where am I adding? Ah, there. Okay, hopefully this will not be a recurring issue, but let's get through it today. I'm going to stop sharing. See whether, and let me know if you get it or are able to share.
So let me. Why does it need micro?
Yes, some of them you may need to skip.
Yeah, I guess.
But
Actually, hang on, let's do one thing.
you would need to run that though.
This right from here, right?
No, the up above that one too. Yeah.
I think I need that.
Yeah, you need that. And then you can skip the ones where I have comments. You may just need the ones where it code is there. Yeah, some of these tests also you can skip in the interest of time because they're just checking for stuff. You can skip all that. You do need the patch too, maybe. But just to be sure, you can skip the tests. Yeah, and then you need the patch. You can skip the tests. You can skip the patch property. You can skip the context manager. You may want to add the add docs. And then you can skip all the tests. That you can skip. Add docs you may want to because it might complain later. And then is it? Oops, what is it complaining about? It did run that, right? Then add docs, then I saw something go red. That, why is that complaining? Name docs is not defined. Is the docs decorator defined up there somewhere that we didn't run? Oh, there, that cell, the export one. Yeah. Then we can run, should be then, well, those are just checks. So that should be fine as long as we ran. Yeah, those are check. Column wrapper you need. There's a test. Is bool you need. Mass to IDs you need. Those are tests. Cycle you need. And that's a test. Zip cycle, yes. Then is indexer. By the way, if you just take a minute, this is used as we saw in L, right? That's where he was using the code of saying is indexer, which says either an int or the end time attribute, which is 0. You see that? Which says that it's a single item in a list. You recall I was talking about how he uses that check to check that is it a single item index, and if so, do something, or is it a multi-item index, in which case I need to do something different. Do you recall that from the L class that we talked about? And that's what is being used. You may need to run get at. Did you run that?
Actually,
yeah, you need. Yeah, then yeah, you can skip all that. All this is explanation. Yeah, that's also testing. Testing. Hang on. That's, yeah, you can run that, but it doesn't. I don't think he uses that. But the rest is testing, and then we are into L helpers. So good. Okay, you can just run. Oh, you do need to run the collection base.
So with what you were talking right now.
Yeah, if you go up to the code, go up a little bit in the L code, further up. Yeah, and instead of set, just go to get. Yeah, see, that's the thing I was talking about. If indexer, then, or even further up to check when new. So that's how he supports multiple indices. Check whether what is passed into get item is an indexer or not. And we saw what an indexer was, right? And then if indexer, call self dot under get. If list, then create a new L containing self dot get of IDX. That's what this does.
Cool, let me run this. Ah, damn it.
Missing something, or oh, you need yeah, it's the one, it's above that.
Oh, did I miss that?
Yeah, you need to run that.
Yeah. All right. Okay, so where do you want me to kind of?
Yeah, so I mean, we just looked at how he gets access to multiple non-contiguous items in L, which it will get successfully returned. For example, setting 3, 5 in values at index 3, 5 to be J and K, as we saw in the cell below. And the code and the comments that I have are the ones which allow you to do that. Otherwise, and it's the same for get and for set, right? And if you go down now and look at the tests, and you can run those. Yeah, as you go down, you'll need to probably run that. Yeah, and run this. Now stay there for a minute. Here is where I was explaining that if you know, the test equal T3H, that a traditional list supports. So why have an L? Well, the L will let you do what the next line does, whereas a list will not. Unless it's 3:5, in which case it's a slice. It will not let you do a traditional list, will not let you do list 3, 5 equals or getting the values. And then this one, I haven't figured out the reason why he does this, although obviously how he does it, we know using a meta class, but I haven't quite understood the reason. It almost seems like he just doesn't want to use too much memory and stuff, because it's like analogous to in place change, right? Because what you're doing is you're not returning a copy or a new object, you're returning the object itself. Right. So that's why L of something and L of something is that something. And we'll see the is test, even though he's just using even though he's doing just the equality test here, it doesn't quite convey what I'm saying, that it is the same object. We'll see him run that test where he'll confirm that it is the same object. You can actually do that here too. Say test is T, L, T. You can do that. And I think test underscore is, and then yeah, T and L, or L of T. Sorry, no, L, yeah, and that should pass. You see? And that's done through the meta class call that he modifies, that we saw up above, just a few cells back up.
This guy.
There.
Yep. Yeah, like the comment also says that.
Yeah, that's yeah. So if we go down for more tests, he does some very interesting things with L. One of the cool things I like is addition or appending from the left.
So this one is done, right? Making more.
Yeah, this one is done. Then you can go to assert is instance sequence. That's where I was at. And then import random. You can do the random stuff. Then the next cell is you can just check with the collections that you can change it, right? That's fairly simple. You're just changing,
okay. Just
yeah,
replacing this.
right, right.
Okay.
Then go to the next cell. And so if you run this, you'll see, oops, what? Why is PD not defined? Well,
I
yeah.
saw that in yours. I don't know.
Yeah, I don't know what happened there. It was there, so. But okay, so here if you see, let's just go through that. So basically you're just making an array and then saying, passing in the array to L, and then checking that T12 is the array 1, 2, right? And now here T of 1, comma 2. So that means, by the way, this I wanted to highlight that T of 1 and 2 actually means the values at index 1 and index 2. Yeah. But see here, if you do it, it's after he has defined it, whereas up above he only uses array. So that's where sometimes I dislike what he does, because he has combined two things. So he has defined PD data frame and then defined T as L, but the earlier thing is an array. So if you want to find those values of T, you need to do a print, or do what you're doing right now. Yeah, get rid of that and define that, and because it's at index 1 and index 2, and you can access it that way.
So that was the new thing that I kind of realized today with this L, is just it's not a hyped up version of just list, but it just even helps you access.
Yes, because exactly, because he's combined the concept of a list with that of a NumPy array type indexing. See, that's the, so it's kind of like a morphed version. I mean, it's a superset of list.
Correct. Plus added
functions. Plus added features. But it's not, definitely not just a list. It has the NumPy array type indexing features. Because you can do in NumPy array, you can do the type of indexing that he is doing, but you can't do that in a list. So that's the cool thing. And in addition, not just a NumPy array type of indexing, but also the data frame type indexing.
Correct.
So that's why this stuff that you have, that I have in the second part works, right? Because a DF is the data frame A, and then you make an L of it, and then I wanted to print T. So T is this, and when you print T1 and 2, you're printing it at indices 1 and 2. That's why T of 1, 2 is this guy at these values. Because again, if you go up in the code, he supports the .iloc when it's not an indexer. That's how you get through the get and get item, the under get item gets passed into underscore get, blah, blah, blah. And then through all of that code, he's able to get access to that.
Correct. Okay. Can I pull that up on the side so we can?
Yeah, that'd be great if we can have it on the side.
What is this?
Yeah, that code, but it's fairly big, especially with my added comments.
How do I do this? Does anyone have any idea?
Well, you can do the question mark L, right?
And
that'll pull it up on the side. No,
that's pulling up the meta though. That's what I tried.
Oh, really? No, if you just give it the L question mark, pulls up meta.
Yeah.
Oh, it says type meta. Oh, it doesn't give you the, that's weird. Interesting, because it is of type L meta. But is that the reason, or is there some other reason of why it doesn't give you?
Let me do it early.
Code. If you can pull a blank help and put it on the side.
Yeah,
I don't know how to do that.
Get this. That work. Still goes down.
It's still, I think the fact that it's not a type class that causes that problem. That's an interesting sub issue that you discovered.
Nope. I guess, yeah, I'll just scroll up and down, I guess.
Yeah, yeah. It's kind of annoying, but okay, if you keep going to the test.
Right. Did we want to look at the iLog stuff here?
Yeah, it just go up then because it's actually fairly simple here, right in the get. Yeah, see right there, it is self.items.ilock list I. If has attribute self.items ilock. So if the collections base is a data frame, because then it will get the self.items will get basically what you're composing is a data frame, then it will have that will have the attribute ilock because self.items will have the attribute ilock in that case. Then you just go self.items.ilock and then list of I, which will just pull out the I values at self.items.ilock.
Right. So this is where that 3, 5, interspersed numbers can be passed.
Yeah. Even from a data frame.
Go back to the tests.
Yeah.
So we finished this.
Yeah, we finished that. So you can also then, yeah, that's the same, but just for a data frame.
Okay.
Instead of an array. So he does it on the top for an array and at the bottom for a data frame. That's it.
You mean this is for the array, right?
Correct.
And this whole thing you have set up is for the data. Okay. Yeah.
Data frame. Yeah. And then now these tests are basically indicating that, if you do an empty, then you get an empty list though. An empty L gives you an empty list. Okay. And then obviously you can do the append, you can do the plus equals, right?
Right.
And you can add an individual item. All those are things which work on a list. What doesn't work on a list is the next thing he does, 5 plus t. That won't work. You can't append from the left to a list.
So now we can do that.
Now we can, yeah. Right. And the next one is also something you cannot do to a list. Not that, but the negative mapping operator.
Okay.
The next two tests just, basically they just show that L of a tuple is again a list.
Right.
Okay, because any collection you pass in, it translates it to a list. And then the next one is L of 1 of 5. So you can do, basically that will create a list of 5 ones, right? But the thing that it's doing next, which is negating the L, well, actually, in that case, it's not negating, it's just multiplying the, sorry, let's take it as a best step. So L1 times 5 just creates a L with 5 1 values. Then mapping the operator.neg will just make those 5 minus ones, and then that's what you're testing in the test equal t minus 1 times 5. So I believe, although I haven't checked out, but that you could be able to do that on a list as well. But what you can't do is the next thing that he says, which
map available on list?
You could map onto a list. I think you can try it right there and see whether that works.
I think so.
I think map should work on a list. You can just put, yeah, and you can try.
No, you have to call map as a function itself in the list and then change it to a list again.
Sorry, can you repeat that, Ando?
Like you have to call map itself as a function on the list. So like map brackets A, then you can now, that will give you an iterable, which can then convert to a list. List itself doesn't have the method map.
So will this work?
Yeah. So yeah, you can now put this back into a list. So
just other way, first operator and then list.
Okay.
yeah, so you put
You have
this
to
back.
list it.
Yeah, exactly.
You have to list, yeah.
So it's like longer. You just made it shorter, like a lot easier.
I see.
Does FastAI datasets been like? Does it have a map method?
Like TensorFlow? I'm not sure.
FastAI datasets, those.
Right.
I wonder if you can map. It's you can use map on Hugging Face datasets,
Right.
but those are different.
Yeah, like TensorFlow basically has the map concept. So I think FastAI transform is very similar to how map works. At least that's
Yeah. But I was also thinking, the transform lists, because they are ultimately lists, you should be able to do the map on them, like we do here, though. They are else, in fact. So if they are else,
datasets not necessarily composed from this L. You can just create datasets from PyTorch tensors or NumPy arrays or whatever.
Yes, so that's why I said, as far as I recall, it's only the transform lists that are else. I don't know that the data sets you can do map on, but it's worth a try to see, because I think those are generators, if I recall. So I don't know.
The data loaders are generators, I think. Yeah, the data sets are just iterables. Yeah, if I'm not wrong, the data loaders are generators.
Yeah.
Yeah, then the data set is just like the iterable.
The problem is he does this, so they do get converted, right? When there's a transform list.
So transform list, see?
Okay.
There is an L. So
if you pass in your items, you will convert it to a list. Capital L.
To a capital L. And then the question is, you can do L.map.
But this capital L is list of data sets, right? Like you have here training data set and validation data set.
I think you're right, correct. Yeah, that makes sense. No, but wait, it's items, right?
Yeah, because if you should look at the get item method, like get item is actually calling that self.tls, which is list. So I remember when you index into a data set in FastAI, it returns a list. So I think you should be able
basically
to
it becomes an L, right? Is what you're saying?
Yeah, it becomes an L rather. Yeah. So I think you should be able to map over.
Should be able to. Yeah.
Yeah.
Don't see him using a map here, but I don't see why we cannot.
So basically transformed list is an instance of L, right? It will be. or not?
I think that is the case.
Yeah, I believe so. But to Arto's point, we may have to try it to see whether it works. But
Yeah, sure.
But if it's an L, then yes. And in fact, here's some very clever, smart, cool uses of map as we go down the tests. That'd be kind of cool to see.
Yeah. Can we map?
It's more data sets.
Right, data sets. So yeah, I can try that next time. I'll see if I can post something.
Oh, cool.
Okay, so if where were we? So what I was saying was, see, if you do the not L, true, false, false, it'll negate it, which is kind of cool. You can't do that for list. And then the next one is, the next test just below where you have it, where you have the cursor is, remember earlier I had shown in an earlier notebook that he created a FastAI cycle, which supports none. In this case, it's not relevant, but he's just zipping the T and the L1 and then applying cycle to the L, which basically says that that's identical to range of 4 because T is L of range of 4, and zipping it with 4 ones. Do you follow what he's doing there?
Yeah, I think, I get that.
Yeah. He's just zipping two things, but he's cycling the L with and showing that all it does is gives you
sorry, please. I can't remember what the cycle do again. Like it's
cycle just cycles through the values.
So it kind of creates like this infinite thing, right? So you can
yes.
Oh, okay, but in our case, it's creating it so that it will be of the same length with T. Yeah.
Yes.
Oh, okay,
yes.
okay.
That is the limitation of zip, though, right?
Yeah, the zips. The zip does it only to the smallest value unless you do zip longest.
Right.
Okay. Thank you.
So that's why it gets cut off at 4.
Thank you.
L1 dot cycle will continue infinite cycle, but the zip, as Rekil is pointing out, will truncate it to the size of the smaller of the two, which is T, which is of range 4, which means it has 4 values.
Yeah. So if we should use like zip longest, we'll probably get a memory
Yeah,
error.
you'll just destroy it. Yeah.
Okay. Cool. Thank you.
This is just checking for shuffle, right?
Yeah, just checking for shuffle. Yep. So, oh, that's something you tried. Okay. I thought, what is that? Here he just applies F and passes it and says, I don't know why he chose those tests or whatever, but you can just use a function and pass in a value, and it's kind of self-explanatory, but I don't know what use or where he uses that kind of stuff. Because he's just mapping the function on to T. Right, and then checking that each time the value that you pass in is actually different because A is 0, so it's whatever X you're passing in, and then you just check that if you pass in a 1, then it becomes a 2 times 5, and then if you make A equal 2, then it becomes 3 times 5, and so on.
Yeah.
Then the next one was a little confusing to me, but that's why I did what I did in this cell, because later on this becomes relevant. he points out that an L can be constructed from any iterable, just as Tendo mentioned. The important thing is tensors and arrays will not be iterated over on construction unless you pass use list to the constructor. So what does that qualification mean? And that's what I was trying to explain in the cell below. So look at the way when you do list of array of 0, it's just 0. List of array of 0, 1, it actually splits the array into 0 value and 1 value and sticks it into the list. Do you understand what's happening in the second thing? Is each of these elements are split. It doesn't treat it as an array of one value, single valued array of having the element 0 and 1 in it. Instead, it treats it as having element 0 and, or sorry, treats it as 0 and 1. So two values are returned in this list, right? Whereas that's not the behavior in that we typically want. So L doesn't do that, right? So L returns a single item list, a single item array when you use it. So that's what now becomes relevant when you check, when you run the tests below. Is that clear or is that confusing?
Like, I'm a bit confused. Like, I'm trying to spot the difference between the result of the first cell and the second cell.
Yeah, that's, see, because it prints the same thing, it's not very clear. But that's kind of why I wrote down, because it wasn't clear when I went through it too. But there is a difference, and it will become clear, I think, when we run the cell underneath, the tests where you have the cursor right now, Rekil, if you run that. But actually it will all pass. But the important thing is the last two tests. So if you see test equal L array 0 dot comma 1 dot 1, right? And you access the 0th value of it, that is the array, that's the array with a single entry array with two values in the array, a 0 dot and the 1 dot 1. Are you with me so far, Tendo?
Yeah.
Okay. Now let's go to the next cell. Test equal L array 0 dot comma 1 dot 1. Use list equals true. Okay. It returns array 0 and array 1 dot 1. That means it
Okay.
unwraps the arrays.
Oh, okay.
Because you're saying use it as a list. If you were to retain it as L, then it will return you a single 2-entry array. A single array which has 2 elements in it, not a list but a list automatically splits it. That's what you see up above. And L does not. That's the difference.
But
Yeah,
that's not recursive, right? So like if we have a multi-dimensional array, it will be unwrapped only across the first dimension.
I'm not really sure. It may be worth a shot to see what happens if we create an array of 3 by 3 elements as we did, as he has up above. And whether it will still return you, he did that thing up above. You could even copy it directly. He had this a range of 9 and then a 3 by 3. And then you can, there, right there. And you can try what happens in that case to check what Artu is asking. And don't have use list is true. Just do that and keep it as use list. And then what are we trying to determine here? You may want to print the T so we know what that is. And then What are we trying to check? Yeah, so we are trying to see what is the check, Arto, that we want to do now.
If this use list works, well, I don't expect it to work recursively. So if we have 3 by 3 list, it should return, I guess, the list of 3 elements, each of which will be 1 by 3 array. But yeah, that is needed to be checked.
Yeah, but the more interesting case is if use list is none and whether L keeps it the way it is, right, and doesn't split
Yeah, and
it.
in this case, it should be like a single element of whatever shape we passed,
Yeah,
right?
yeah. So if use list is none, and then you just, I think it will be a single 3 by 3 elements.
1 by 3, right?
T0, right?
So let me just
Not array 1, 2, but
print, right?
sorry.
You want me just print T0?
Yeah, yeah.
Ah, so that's what T0 was, and yeah, this is what we expect, right?
T is all that, and then T0 is the array 0, 1, 2.
Right.
So when it's used as a list, maybe try is list to go through. Let me see what the first is.
No, not there, not there. It's because there it will split it when building the array itself, right? You want to do it when do you want to do that?
Wrap it up separately and then do it.
We want to do it to check what? Oh, 0 useless is true. Okay, what is that too? Yeah, see, now the thing is, the printing of it is, I think,
Yeah,
here
that's when you do this.
Yeah, but see here it's showing that it is 3 elements, 0, 1, and 2. See here, whereas here, if you don't have useless true T0, it will say that it's single. Print T0 and don't have useless true. Do the same thing. No, have both of them. Yeah, and you can just do print because otherwise it won't print. Yeah, and then have under there. What happened? No, you're making it. Yeah, why is it not printing the?
I think that's just a retro of L is mentioned like that, right?
No, but it should give you the
Okay, but that's only
the number of elements in it, right? So what when you printed just that, it did that, right?
Right.
Why is it not? Yeah.
I guess how print works with L is confusing because it does not display this number of elements and it just prints.
Yeah, and try in an Excel Rekil just without useless, a separate cell.
So if you want me to do just L?
L, T0, useless none. Yeah, see, it's a single entry array.
Yeah, I don't get the difference between this and this.
Those are 3 elements in the, it split the elements into 3 individual 0, 1, 2 entries. It's not a single array of 3 entries. The difference between the top and the bottom is this is 3 elements in a list of 0, 1, and 2 because you have said it, treat it like a list. Below, it's a single array of 3 element in it,
Basically,
right? But it's not a 3 elements, it's a single element array.
Can you do it now with the initial RRR scene? Yeah, both this cells with as instead of T0 use the ARR.
No, leave those. Use new cells. So we have stuff to compare.
Yeah.
Array may not have use list, right? Oh. Yeah, so it's saying now that L has 3 array elements in it. It's a single element 3 entry array.
Yeah, makes sense.
Yeah, I'm just trying to like picture a use case of because well, okay,
Yeah.
I think the thing like is the first one, like the one above that is a which is that contains like three individual arrays. Since it's like a list, it can't have all this indexing like row comma column indexing anymore, unlike the second one.
Yeah.
Like,
So sorry, go ahead.
like what I mean is that since the first one is like a list, you can't like index it with, let's say 1,2 or something like that. But since the second one is an array, you can actually do that like brackets one, sorry, square brackets 1,2. Since you know it's an array and it supports multi-index. Is that like the only? Because I'm trying to like picture a use case like why when I would use something like this.
I think in this case, what he, yeah, that's where looking through the code to see where he's actually utilizing this feature of L is interesting. I haven't done that, but just thinking about it, the point he's making is often when you want to index in or in, you want to index into the array itself as an array and not as, don't want it automatically splitting it into its elements, because then you're losing the array aspect of it. So that's what I took away from what, and in fact, if you look at the test, that's kind of what he's checking.
You can still access into each of them. I mean, I guess it's just in.
Oh yeah, accessing, yes, but it's what it automatically gives you back is the array itself, so that if you then use it to index, you know what you're getting, right? Because it depends on what you expect the result to be.
Yeah,
And
yeah.
then typically you would expect the result to be retained as an array, not split into its elements.
Yeah,
Because
so
then
it's like returning type, basically.
yeah. Whereas if you do the list, then it breaks it up into its elements. So for example, that's why the simplest example of a 0 and a 1 2 or a 1 2 example is relevant, because you don't want it to split into 1 and 2. You wanted to retain it as an array 1 2.
Oh, okay. Okay.
So basically, this L doesn't add anything in case if we use list is none, right? It's just an array.
Yes. Whereas it also highlights what list does, which is to break it up into its constituents.
I just asking if there is anything extra you get when you wrap your array into L.
No, I don't believe so.
Yeah, I just
Yeah, I think what of the fact that you can like append things from the right, does that work with normal arrays? I can't remember.
Yeah, don't know. You'll have to try. If you go down trickle to the check, and I don't know whether you can append to an array. If you just give it an array of 1, 2, and you try and do a, but well, it has to be made into a L, and then you can do it, I would think.
Right, you want to append.
Yeah, but it wouldn't do operation on array. It would just append another array to a list.
No, like what I mean is like if I'm not wrong, what I think Arthur is asking is the difference between like an L and an array. Yeah.
Yeah, I mean, I was asking if you use L on array,
Okay.
and set use list to none, you just want to get array back with nothing added to it. Is that right?
No
Okay.
change.
Yeah.
Right.
Well, I don't. Yeah, go ahead. Go ahead.
Sorry, Arthur, this is the question, right? So if you use an array and your set use list is equal to none, converting this to this L should make no difference. That's what you're saying, right? It should be the same as the array itself.
Yeah, I mean, just from a perspective of use cases, you know, like if you pass your array, some array to L, and with use list none, you just want your array back and nothing changed, right?
Right. I guess you
Yes.
have this extra functionality of whatever L provides now, right?
Yeah, but would we get any extra functionality?
Yeah, that's true, actually. Good point. Let's see. Like, don't we get... Yeah, that's true. You don't get any of...
Actually, you might if we wait till we look at else methods, because L has a method that applies to an array which an array might not have.
Maybe, yeah, you're right.
So you would get else methods to act on an array when you send in an array to build an L.
Mm-hmm.
Yeah,
So
first you can just check a type of this error none.
that would be an L, or whatever that what meta da da da.
Yeah.
Yeah, it is an L. Yeah, and else methods, there are methods which L has that add beyond array, Arto.
Okay.
We haven't gone through that yet. So that's where I said there were some cool methods. So for example, right now here is one, and he obviously shows it for a list, but you can try whether that is, if you provide a match, then you, if match is not none, then you created list is the same length as the match, and if the length of the items is 1, then it's just replicated. Then it's just replicated. So you can see in the test code how that works. If it's 1, then its length is 1. But you're specifying, you're giving a single value, and match is a 3-item list. Then the length of match is used to multiply the single item from the from what is passed in. So that's why you get 1, 1, 1. But if the left, meaning the thing you pass in to build an L, is not a single item, then the length of match better match the length of L. Otherwise, it will complain.
So what are we achieving by doing this here? The second
In that case, nothing other than checking that its length is identical to what you want, what you pass in for match. Right? But the first case, it duplicates.
Right.
The second case, it just checks.
What does the 2 and 3 signify here?
Not the values don't signify anything. You can make that 3, 4, and it'll still be the same.
Okay, that's what I was wondering. Does that? Okay. This is just
because it's the length of match that matters. If you see what's mentioned above.
Right. Okay, now that makes sense. Okay.
And obviously that's there in the code for L up above.
So this is basically items. So if length of items is equal to 1, then items is replicated. So that is this case.
And so how would it work with if we have not if we have array here?
Let's see.
Like NumPy array.
Yeah, then your match should also have the same, I would imagine, shape.
Yeah, so would it like expand the array or just duplicate array multiple times?
It's just one without this right square. Yeah, okay.
So now you're asking Arto if we make this like 1, 2, 3?
Yeah.
No, one or multi-dimensional.
You see,
more
it
like,
just works differently with list and with array in this case.
Isn't it doing the same thing?
Yeah, it's multiplying the single entry array into 3 entries of the same values.
Yeah, but like, look, when we had a list of 3 elements and we wanted to match it with like...
No, but there it was just checking the length, right? In the second case, it's checking when you give this, it's a non-single entry here. So its length of items is not 1. So here the length of items is still 1 because it's a single entry array with 3 values inside of the array. It's still a single entry array.
Yeah, I see. But just I wonder if that's what I would expect when I do the same. So in some cases it acts like equivalently with arrays and with lists, but in this case, for example, it would treat an array as a single element, not as a sequence of elements.
Rather, if you do like a list of no, there. Yeah. This makes more sense if we know where the use case specifically is, and like you say, like after that.
My own query is like, why didn't he just make this match to be something that we can just pass in the length we desire instead of actually passing in a list to match? Is there like...
I don't know, like for example, I would say that if you're passing in, this is like maybe let's say file names, right? And for some name, you want to have something which is constantly repeated for all those file names. Maybe that's what something is there. Like when you read in from get file names, you basically return an L with all the file names. I mean, there are other ways of doing it. I agree with you, Tendo, but yeah, this is where I think FastAI pushes it a step too much.
But again, if we do it with arrays in both cases, it wouldn't work, right? As we it will just treat both as single element, right?
Yeah, I think that's right. Yeah.
Okay, and if you go down, then the test that I talked about is right there, right? And I checked that it's not true for a list. You see what I mentioned? Of course, we have played around with T, I think. So I don't know whether we have the right T, but you know, L of T and T test is, which we already ran, whereas I tried it with a list.
Okay. Right. Okay.
Doesn't work, right? Because it returns a copy.
Oh yeah, because this returns a new thing. when you do list of, right, okay. Right, okay.
And then this is just something that he says is true. Test equals AB is just the list, but it's never considered equivalent to a set or a dict, even if they have the same elements.
Okay. You can convert a dict to an L, right?
Oh yeah, absolutely.
How does that work? What does that convert it to? Just as key value pairs, or?
Yeah, I believe so. Because that's what I thought I saw. In fact, he has that in the tests above. We never have looked at all the cases there. If you go up, oops, I think you might have a built-in. If you just go up to that guy, hang on. Sorry, that guy. No, the one below that. Yeah, there. Now, if he does he have no list dict there? I thought he did. Okay, then you may want to build one.
Yeah, these ones are the ones which
All
are,
arrays, yeah.
and then you have this
String.
right. Yeah, let's see what L does.
Yeah. And we should get wrapped up because I think the hands-on machine learning will kick us out automatically.
Oh yeah, it's 10:55.
And we can start with L methods. Then, yeah, see, it creates a 2-entry of just the keys.
Interesting.
Oh, cool. Cool stuff.
And if we'll start with the methods next time, hopefully I won't have the disaster with notebooks I had today. But Rekil also has the notebook, so
yeah,
you have a backup.
Yep. Yeah.
And I'll send you my I'll send you my basic notebook too, just in case, so we can switch quicker than this time. Next time,
Yeah.
I'll share it with you once I
Sounds good.
update it.
Yeah.
Okay, cool. So Rekil, if you can look at various L use cases maybe next time of some interesting, and in fact these array things, if you find matches and stuff,
Right.
that'd be kind of cool.
We'll look at, yeah. This will be a long one, I think. Quite a few.
Yeah, and maybe look into what Arto asked of a data set.
Right. Using map on
And yeah, running map on it.
Yep.
Okay, cool.
Thank you.
Thanks for joining, guys. And one more thing. I think given people asked, if all of you are still motivated, we can still have it on 26th. If not, we can skip and go to the 2nd. What do you people want to do? Skip a session and have it on the 2nd, or continue on the day after Christmas?
I won't be in town. So
okay, so then let's just do it on the 2nd. I'll send out a message saying we'll skip next Sunday and do it on the 2nd.
Sounds good.
That's better. Yeah. Thank you.
Okay, sounds good. Have a Merry Christmas and a Happy New